In this video, we're going to go through the basic concept of classes. I'm not going to get into a lot of specifics. I'm really wanting to just kind of cover and give a broad overview of what classes are and why we use them. There's a huge debate out there right now as to whether actually having classes it results in any better code than we used to create with C, which doesn't support classes. Go's another language that doesn't support classes. I'll try to explain some of the pros and cons of classes as we go through this discussion. But overall, most languages, especially Java, Objective-C, the whole purpose behind Objective-C is to add classes to the C programming language. So I'm going to try to touch on the specifics about why we have classes and what the differences are. So to get started, I want to start with how we actually did things in C before we had the concept of classes. So if we had, for example, a function, and let's say that it was called xy, and we had one variable, and let's just say that it's an integer and its name is going to be I. And then let's just, for the sake of argument, I'm just going to do this to kind of show what that function does. There's nothing really here. It's just the code is inside of the little curly brackets. Now, this function does a certain thing inside of the program. And then later I come in and we add another function, and this is function yz. And we'll just say that it doesn't have any parameters and it serves another purpose inside of the program. And then later we come in and we create another function, and this function serves yet another purpose inside of the program. Now maybe this function here calls yz and does something while it's doing its thing, and then maybe we also have a function down here. Well, if I can stick to my format here, if we have another function here called AB, and it actually calls xy and passes it a 2, and let's say it also calls yz, and then it does its thing. Now what I'm doing here is I'm actually creating a bunch of different functions inside of my program, and all of them are either standalone functions, which is kind of what you see here with yz and xy, or they're functions that actually call other functions and do different things, and maybe they call 20 different functions and to do a particular task. The point is that before classes we had a lot of standalone functions that did their own little thing, and there really was no way to hide those functions from other programmers that might use our source code. So in other words, I may have a design flow here where I know that it is okay to first call this, then call this, then call this, and if you use my particular program or my particular source code, I am going to make sure that you always call this XY function, then call this one, and then call this one. Well, the problem is that because I'm giving you my entire source file, I have no control over which functions you're going to call, what order you're going to call them, whether you even call certain functions that you need to call to make sure the program works properly. There's a lot of control that I lose with being able to work with other developers and do specific tasks. So the concept of being able to create an object that can do certain things instead of just a bunch of individual functions was a pretty powerful thought. So to give you an example of how this might look, if we were to come in here and we'll just clear this, and let's say that instead of creating all those functions, we create a class, and I'm going to go through and try to explain this as much as I can, but let's say we create a class called AB. And inside of this class, I have some functions. So let's say I have a function called AC, and we have another function here called AB, or we'll say a capital B. Another function here called ZY, and so forth. So we have this class that is doing its thing, and it's going through and creating a bunch of different functions. Well, at this level, I really haven't done anything different than me having individual functions. I've named everything through a class, but I haven't really done anything different than, the C way of doing it. This is where things start getting interesting, though. If I were to come into my class and say that this is a private function, then basically what I've done is I've told anybody that creates an instance of this class that they can't call this function. The class doesn't even show it to them. They can call this AB function here, and let's say that the AB function actually calls AC. So that function goes out and handles calling this AC function, but they can't call this themselves. They have to call AB. Well, what this does, is what it starts to do is it starts to give me control over the order things are done and the way things operate. Now, this gets to be really powerful. The one key thing, and probably the most confusing thing for new programmers, is the difference between a class and an instance of a class. And my best definition of this is, if I were to go out and let's say that I'm going to build a truck. And so in order for me to build a truck, I'm going to go out, I'm going to get me a piece of paper, and I'm going to start drawing me up some blueprints. So I've got a blueprint of what my truck looks like. So we have our blueprint. Now, this blueprint that we have is the class. So all of the code that I'm writing over here is the class and all of its definitions, how big things are, how fast they are, what functions are going to call, what variables make up this particular class, and so forth. But this is not an instance of a class. In other words, I can't get my blueprints out and drive down the road. I can't load gravel on the top of my blueprints. I can, but it's not going to be very functional. So I need to at some point build a truck. So when I actually go over here and start building my truck, and we're going to, and this is just an awesome illustration here, but when I start building my truck and we want to load gravel and stuff into the back of my truck, I actually now have what is referred to as an instance of that truck. So I now have a truck. When I'm working at the class level, so this is the class level, this is the blueprint. This is where I'm actually going in and writing my code. The truck is the actual instance where I have created an instance of a truck or a printer or whatever it happens to be that I'm writing the program for. So you have to get in your head the difference between having a class and having an instance of that class. So as an example, we have class AB right here. At some point, I'm going to come down here and I'm going to create a variable. And you remember how we created a variable of type int. Now I'm going to create a variable of type AB. So I'm telling it that it is a type AB class. I'm going to call it G1. And then I'm going to say that equals a new, and again, this depends on the language, but I'm going to create a new instance of AB, for example. Let's just say that's the way you do it in the language that you're using. So what I have done here is we have actually created an instance of the class that we defined up here. So we write our class, we do our stuff, and then when we're ready to use it, we actually go and create an instance of that class. Now, there's also a concept of this or self, depending on the programming language that you're using. When you're writing these functions, if you need to have that function actually operate on the instance of the class that got created. In other words, think about when you're writing the code, you're writing the blueprint. Well, that blueprint is not really an instance of the class, but I want to actually modify, let's say, a variable. Let's say that this particular class has a variable called V1 in it. Well, if I want to work on the variable V1 that is instance of this class, inside of my function here, I would actually say this dot V1 equals, let's just say hello. So this is referring to the instance of the class. It basically gives me a way to refer to the instance of the class while I'm writing the code, because obviously while I'm writing the code, there is no instance of my class. So I'm kind of having to, envision what it would be like if I were an instance of that class. So the word this or self, depending on the programming language, gives you the ability to refer to a specific instance of that particular class. So classes are a very, very powerful abstraction of your source code. It kind of gives you the ability to create actual objects or the appearance of an object that can do certain things, and then the outside world, the programmers that are using that instance, have to do things the way that the blueprint dictates. In other words, I can't go open up the car of my truck or the door of my truck by using a jackhammer. There's a handle on the truck, and in order for me to open the door, I need to go and pull the handle and open the door. If I want to roll the window down, there's a knob that I roll the window down, or a button that I push to roll the window down. So I have in the blueprint, I have specified the ways that you can interact with that object, and then any programmers that are going to work with your source code have to work with it through the blueprint that you've laid out in your class definition. So just think about classes as a group of functions that you have put together to make something happen or to make something work a specific way to make it easier for other programmers to work with your source code.